Anyhow, okay, let us consider the type of strain gauges. Everybody write down this subheading. This I will share, don't worry. So, heading right down types of strain gauges. Types of strain gauges. You see on the screen, strain gauges can be made up of metallic element or semi-metallic element. So basically it is of two types. So if you consider metallic strain gauges, it can be of bounding type or unbounding type. What do you mean by bounding? What do you mean by unbounding? I will discuss. And in case of semiconductor also, it is belonging to bounding category. So semiconductor strain gauge also belongs to this particular category, bounding strain gauge. Okay, if we further see the down part of bounding metallic strain gauge, so it can be a wire type or metallic foil type or rosette type. Is it clear? The tree structure of
Yes, sir.
strain gauge types.
Yes, sir.
Okay, I'm moving further. So I have written some text also so that it will be a quick reference for you. Unbounded strain gauge actually are nothing but the old type of strain gauge in which there is one movable part and there is one fixed part. The force is applied on the workplace. So what happened because of that? The movable type element get either compressed or either it will get tensile force or compressive force. So either it will go in or move out. So because of this, what happened? You see, there is a wire connected between a movable arm and fixed arm. Are you able to observe this thing? Wires?
Yes, sir.
Yeah, they get either stress or they get compress, due to which some strain get applied, and that we can measure with the help of the means available. I will explain you what are the means available with the help of which the applied stress or the strain can be measured. Okay. Okay. Anyhow, I will tell you straightforward right now. There are two methods available with the help of which the applied stress can be measured. One is Wheatstone bridge, another one the potentiometer. Okay. Hope it is clear to everybody. The
Yes, sir.
construction, the
Yes, sir.
construction of unbounded strain gauge. Okay, just I will read this text. The unbounded resistance strain gauges uses strain sensitive wire with one arm fixed and other attached to a movable arm. When the strain is connected to Wheatstone bridge, initially when there is no load applied, then what happens is all four arms give equal amount of contribution of resistance, then the resultant output voltage will be zero. Okay, maybe you have already seen the procedure to acquire output voltage from Wheatstone bridge. Have you seen Wheatstone bridge before this? Yes, no.
Yes, sir. Yes, sir. We
Yes,
have
sir.
seen
Yeah.
Western Bridge.
Okay. Do you have any idea about Wheatstone bridge?
Sir, four resistors on the opposite side.
Yeah.
It will be in the like a square form. One
Operation.
potentiometer.
I'm,
Potentiometer
I'm,
is attached.
I'm interested in knowing whether you know the operation or not. When all four resistors are equal, what happened to output voltage? The output voltage is zero, right?
Yes, sir.
If yeah, what we will do is one of the arm is actually subjected to change in resistance. If that get changed, what happened? The potential which is getting recorded from the Wheatstone bridge will be giving you output voltage according to changing that arm resistance. So that is the operation of Wheatstone. Okay. The remaining theory about this we will see uh, in maybe next class. Okay. When the strain is connected, okay, the resultant output voltage. Okay. Application of this is about when no strain is applied. Application of pressure or stress causes a small displacement which causes a change in resistance, increase in resistance or decreasing resistance based upon the type of pressure which is applied. So this causes unbalance in the output voltage of Wheatstone bridge, which is proportional to the change in displacement. Hence the change in applied pressure or stress. Hope it is clear to everybody.
Yes, sir.
Yeah, this device is less robust. That's why this is obsolete. In very few applications, we are using this thing. Uh, Mostly we go for bounded strain gauges. Okay, bounded strain gauge. In case of bounded strain gauge, the theory is uh, the workpiece on which the force is applied is actually bounded or fixed to one substrate, right? That's the name given to this thing. Bounded strain gauge are so called because they are attached to some surface. In bounded strain gauge, resistance element is cemented. Cemented means fixed to the base, which may be a thin sheet of paper or it may be a thin sheet of bakelite or Teflon. So let us suppose that this is the workpiece, okay, and this is the surface. So this workpiece is actually cemented to this particular surface. Okay, the bounded strain gauge for measurement, again this is also connected to Wheatstone bridge. As I told you, there are three types of bounded strain gauge. One is wire type, another one metallic foil type, another one rosette type. In case of wire type, single wire is actually used in order to sense the applied force. And in case of metallic foil type, okay, the metal foil is used instead of using a thin wire. A metal foil is used, which is in all the cases the theory is same. Either it may be wire or it may be metal foil or it may be rosette, all fixed to a substrate. Okay. In case of rosette, the strains that are parallel to the strain axis are measured by a single strain gauge, whereas if there are requirement of measurement of strain in one or more direction, actually this is used for vector measurement of strain. You see, if the direction of applied force is single, we use only one set. Or if the direction of three, like in case of our mobile phone, we have this type of setup. So in that case, we use more than one set of metallic foil. Hope it is clear to everybody.
Yes.
Yeah, if more directions are needed, more, you see, one wire. This is for one direction, and this is for another direction. This is for another direction. This setup is for two axis, and this setup is for three axis. This setup is also for three axis measure. The type of adhesive which is used in case of bonding strain gauges are epoxy adhesive, ceramic cement, cellulose nitrate cement, cyanoacrylate cement, polyamide adhesive, phenolic adhesive. The reason why I am giving this information is in case of theory examination, you need to support your answer with this content. That's why the theory is added. Hope it is clear to everybody. Can I move further?
Yes.
Yeah. In case of semiconducting strain gauge, instead of metal, we will use semiconductor. Rest all same. Yeah. In case of semiconducting strain gauge, you see the basic principle of operation of semiconducting strain gauge, as I told you, is piezoresistive. That is also piezoresistive only. What the meaning of piezoresistance? Piezo ka matlab pressure. Resistance means input is pressure, output is change in resistance. So this particular setup is actually converting applied pressure into change in resistance. Hope it is clear to everybody. Yes, no.
Yes, sir.
Yeah, photovoltaic cell. What is the principle of photovoltaic cell? It is again made up of semiconducting material. Light energy is converted into electrical energy, correct? And
Yes, sir.
in case of this particular principle, applied force can be converted into change in resistance. So just one information I will add to this thing. These days, people are using for powerless. One second. For powerless. Not powerless. This thing, battery less. Not even. Yeah, yeah. That is actually called as uh, supplyless, supplyless IoT devices, supplyless IoT devices. In this case, the type of supply we will apply is nothing but harvesting type. It may be belonging to the category of piezo resistance, or it may be belonging to the category of what is that called, which extract information from electromagnetic field. I forget the name, which extract information from electromagnetic field. So in case of, I'm talking, maybe I'm diverting the topic. Just a moment, listen to this particular thing. Let us suppose that this is our IoT, Internet of Things, one device which is used to measure fire of the fire trigger in our forest, right? So in forest, we cannot provide every time the battery. There is no battery available. Nobody can go there and apply the battery. We need to think of some device which can generate power by itself. Are you getting this point?
Yes, yes.
Yeah. You may ask me a question, why can't it be equipped with solar cell? The problem with solar cell is it needs continuous maintenance operation. That's why for this type of devices, we don't use solar cells as the source with the help of which the power can be always extracted from the surrounding. However, these are the two means available with the help of which the power can be extracted from the surrounding. One is piezo resistance method, another one electromagnetic field method. So more than that, I cannot explain you right now. I can just explain you one introductory information. That is nothing but in this type of setup, what happens is the air pressure is actually subjected to an element which is under piezo resistance. Okay, and it with the help of which we can generate the power at the output. Hope it is clear to everybody, and that can be used as power source for our batteryless or supplyless IoT devices. Anyhow, I want to come back to my topic of discussion. So, in case of semiconducting strain gauge, we use the same principle, but we know that in, semiconductor applications are different for different. The principles also get changed for different application. That's why, in particular, remember this thing: the semiconducting strain gauge use is actually termed as piezo-resistive effect principle. The principle which is used to measure semiconducting strain gauge is belonging to this term, this category, piezo resistance effect, meaning input side is applied pressure, output side is accordingly changing resistance. Hope it is clear to everybody? Yes, no?
Yes, yes, yes.
Yeah, the change in resistance here also can be trap or tap with the help of again the Wheatstone bridge, right? So the germanium or silicon can be used as the material to manufacture semiconducting strain gauge, or it can be positive. It can be generating positive value, or it can be generating negative value based on the type of doping which is used. Okay, this is important as I already discussed. The gauge factor of semiconducting strain gauge is very high. Typically, how much I told you? 100 to 200, plus or minus. Is it clear? Yes, no?
Yes, sir.
Yeah. The another advantage which is mentioned over here is hysteresis effect is excellent. What do you mean by that? As there is no magnetic effect seen in semiconducting strain gauge. That's why the hysteresis effect is looking to be excellent. That is nothing but the relation between change in input and in increasing order as well as in decreasing order will be mostly same. Okay, the size obviously very small. The size of semiconductor is very smaller than metal, right? Because semiconductor can be down integrated, but metal cannot be down integrated. So you see, the implementation of semiconductor can vary from uh, uh, VLSI. Have you heard about VLSI? Yes, no. Are you listening to
Yes,
the
sir.
class?
No, sir.
No, no. Okay. The integration can be on meters, millimeters, nanometers, or even picometers, nanometers. Okay, up to nanometer. Okay, let us consider this case. The meaning of this thing is the basic element in case of implementation on semiconducting field is nothing but implementation of transistor. Transistor. Transistor is having two dimension. One is length, another one breadth. L into M suppose. So this L into M, in case of millimeter implementation, it is 1 millimeter. In case of nanometer implementation, it is 1 nanometer. So the size of one transistor is 1 millimeter. In case of millimeter implementation, and in case of nanometer implementation, it is 1 nanometer size. So with the help of transistors, we can implement the big circuits. Okay, all semiconducting implementation can be brought down to millimeter range or nanometer range. That's why the size of semiconductor can be claimed to be very small in comparison to metallic strain gauge. Hope it is clear to everybody. Yes, no. Okay. This point is not clear.
Not clear, sir.
Okay. Next, as we all know that there are few disadvantages connected with semiconducting implementation. One is its high sensitivity. One is its high sensitivity, and another one, the sensitivity dependence with temperature. Right? The change in resistance causes variation in sensitivity. So what do you mean by sensitivity? If suppose the frequency of output generation is now suppose 1 second, 1 second is a little bit too high, 1 millisecond. The moment temperature increases, its sensitivity become millisecond, microsecond. So the meaning of this thing is with different values of temperature, the sensitivity value will get changes. That's why so it is not advisable to rely on the core type of or the semiconducting implementation of strain gauge without having the shielding or protection against the temperature. So always remember, all implementation of semiconducting element in electronics have problem associated with temperature. The second thing is we all know that semiconductors are non-linear implementation. Agree or not? Do you agree with this statement?
Yes, sir.
Yeah. That's why the linearity of semiconducting implementation is poor. Expensive is not true. You cannot write this thing. The implementation of semiconducting these days are less expensive than metallic implementation because it can be done in mass production, and even a machine can do this thing. That's why it is no more expensive implementation. You don't include this one, right? Hope it is clear to everybody. Can I move further? So
Yes.
this is the diagram. Same thing. Electrodes are there. The connection between the semiconductor conducting material which is exposed to the applied stress, and the electrode is actually done with some high conducting mean. Usually the gold leads can be used for that. This topic I want to discuss in next class. Anyhow, at least this much I will explain you. But before that, I want to discuss this thing. Right now, next topic, means to measure strain or stress from strain gauges. Are you ready for this? Yes, no?
Yes, sir.
Yeah.
Yes, sir.
Maybe I will not be able to take class on Thursday because final year Viva is there. I am examiner for that. So today and tomorrow, whatever we cover, that much only will be there in internal examination. Okay. There will be many means, but in our course we cover two means to measure strain. One is potentiometer. Another one, Wheatstone bridge. Okay, if somebody asks you a question, not like this, do you know the means to measure strain gauge? Not like this. If suppose somebody asks you a question like this, can you suggest some mean with the help of which we can track this information? Change in resistance. So what is the mean you will suggest? How to measure change in resistance? Please answer.
Voltmeter, multimeter.
No, 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 no. The same setup we can use. Potentiometer or Wheatstone bridge. What is that strain gauge generating at the output? Change in resistance only.
Resistance, right, sir.
Yeah, that only we are measuring now with the help of potentiometer or Wheatstone bridge. Yes, no.
Yes, sir.
Yeah, actually, two ways the question can be framed. One is, what are the means available to measure change in resistance? Same answer. Or what are the means available to measure stress or strain from strain gauges? Same answer. Potentiometer or Wheatstone bridge. Hope it is clear to everybody.
Yes, sir.
Yeah. Let us consider first case, potentiometer. Let us suppose that this is fixed resistor and this is variable resistor. In our case, it is suppose strain gauge. Is it clear to everybody?
Yes, sir.
This is fixed resistor and this is strain gauge resistor. For simplicity, at rest, let at rest consider R1 is equal to R2, meaning the value of R1 is taken just similar to R2, okay? But this R2 get changes when applied strain, make it different, right? So when strain is applied, what happens? This R2 become R2 plus
R1.
delta R2, small
Delta
variation,
R2.
right?
Right, sir.
It moves from R2 to R2 plus delta R2, right? So at rest, it is like this. And how about the voltage, which is measured at the output of this R2 according to voltage division rule? It is V into R1
R
divided by R1 plus R2, right?
R1 plus R2. Yes, sir.
Right? Yeah. So this output voltage, if we measure the output voltage with this relation, we may not be able to measure the small change in output voltage due to small change in R2 resistance. So in order to measure a small variation in V out due to small variation in what? बोलिए R2, right? What we will do is differentiate V naught with respect to बताइए R2. Is it clear to everybody? Yes, no?
Yes, sir. Yes,
Yeah.
sir.
This particular expression can be used to measure the output voltage for bigger variation in R2 or bigger variation in R1. We fix V in, we fix R1, right? There is only one variable in this particular equation. So this equation can be used to measure or sense bigger variation in R2. But for small variation in R2, it is not advisable. For that, what we will do is we try to differentiate this equation with respect to R1 and use that particular relation in order to sense the small variation in R2. Hope it is clear to everybody. Can I move to next page? Yes, no?
Yes, sir.
चलिए. Okay. We have this equation. V naught is equal to V in R1 divided by R1 plus R2. So this is constant, this is constant, this is constant, and this is
R2 is
variable.
variable.
Yeah. So
Right.
therefore, differentiate this equation with respect to R2. So we will get right. Can we get like this? Yes, no. U by V. Differentiation using U by V rule. Can we get like this relation?
Yes, sir. Yes, sir.
Okay. Now solve this equation. Is it okay? Can we get like this? Yes, no.
Yes, sir.
Remember, we are considering R1 is equal to R2. Can we write like this? Yes, no. जल्दी बोले तो जल्दी होता
Yes,
देखो.
sir.
Just now I told you, for simplicity, I am assuming R1 value equal to R2 value. That is at rest R1 and R2 और मान लो आपका स्ट्रेन गेज आप खरीदे 100 ohms का है वो, ठीक है? So at rest R1 and R2 are same, right? Yes, no.
Yes, sir.
That's why I'm writing in place of R2, I'm writing R. In place of R1, R2, I'm writing R. R plus R is equal to 2R, 2R square. Is it okay?
Yes,
Sir,
sir.
above R1 square will come, sir.
नहीं जी बाबा, क्यों आता बोलिए?
dV0 by R2, dV0 by dR2 है ना सर?
हाँ तो V देखो V into differentiation of U minus U into differentiation of V divided by
U into differentiation of V, right, sir?
तो कहीं को आएगा न्यूमरेटर में
V
स्क्वायर
square. V
डिनोमिनेटर
square.
में.
First one correct है सर. माइनस R1 है देखो सर.
हाँ हाँ उसके
हाँ,
बाद
माइनस R1 की जगह पे सर और एक एक डिफरेंशियल
हाँ हाँ ये ब्रैकेट में क्या
R1
आएगा?
प्लस डिफरेंशिएशन ऑफ R2.
R2 प्लस 2 आएगा. ठीक है ना? यस नो? देखिए R1 is as it is. डिफरेंशिएशन ऑफ R1 प्लस R2 क्या
राइट
होगा
सर,
बोलिए
राइट सर,
आप?
राइट सर, राइट सर, राइट सर।
ठीक है बाबा, द टाइम नहीं है अपने पास,
सर
इसलिए मैं
R1
पास।
0 हो जाता, R2 1 हो जाता।
हाँ, मैं इसलिए थोड़ा जल्दी करो, आप लोग
ओके सर,
बाद में
ओके
देख
सर,
लो इसको। ठीक है,
ओके सर,
ठीक है, चलो।
ओके सर।
हमारे को यहाँ तक आ गया ना? इज इट ओके अप टू हियर? So because we want small change in output voltage, so I'm keeping here. I'm writing like this: V in R. This R square become uh, uh, 4R. Is it okay? Can I write like this? I'm cross multiplying. dBO is equal to V in into RR get cancelled. DR divided by 2 square 1R get cancelled. Is it clear to everybody?
Yes, sir.
हाँ,
यस
अभी
सर।
चलिए। हाँ, recall the equation of G. Equation of G. We know that G is nothing but
डेल्टा R by R,
हाँ,
डेल्टा
R by R
1
divided
plus
by
2V,
हाँ, divided by strain.
डेल्टा L by L.
हाँ, this is
Yes
nothing
sir.
but delta L by L, right? So can I write like this? Delta R by R is equal to G into epsilon, right? Therefore, small change in output voltage can be written as V by 4 into G into the strain value. So this is the relation we can use between the change in output voltage with the applied strain. So these things are constant. These things are constant. You see, the change in output voltage is directly proportional to applied strain. Hope it is clear to everybody? Yes, no?
Yes, sir.
Yeah. So with the help of potentiometer, we are getting relation like this. The change in output voltage is 1/4 time of input voltage into G into E. So I will explain you. This type of relation is actually giving poor sensitivity. Poor sensitivity. Huh? Reason is, you see, we are actually dividing the input voltage by 4. Right here, we are making the input voltage less by 25%. Input voltage कितना apply करते हैं devices को 5 volts. So due to which the input voltage become how much? 5 divided by 5. What is of 25? 75% of 5, maybe 3.5 by 4 is equal to 3.75 होता.
Yes sir.
ठीक है. अब इधर देखिए, you are making the input voltage down from 5 volt to 3.75 volt. Therefore, we need to play in between 0 to 3.75 volt, not between 0 to 5 volt. That's why less possibilities of output voltage will be available in our system. That's why it is called as poor sensitivity case, right? Hope it is clear to everybody.
Yes sir.
Okay, quickly. Okay, I think time is up. I have one more class. In that, I will try to cover this thing. Anyhow, I will give at least introduction to this part. The other means of measurement is nothing but measurement of strain gauge with the help of Wheatstone bridge. Detail about this I will discuss in next class. Right? इधर देख लो आप लोग गौर से.